Did it start yet? Oh, let's see. It's saying recording with like 3 points. I'm not sure if it started or not. Yeah, we're just gonna assume it's started. Yeah. So in today's meeting, we're gonna be talking about the what was it called? The Dijkstra's algorithm. We had a challenge to solve last time, and yeah. So who wants to share it? Nick, have you solved the challenge?
No, I haven't. I have solved it something like 9 months ago. So yeah, I'm not sure if I can repeat it now without seeing it first. I remember vaguely. I remember the steps.
Okay.
Which coding challenges you said?
It's like we set the coding challenge last week, which was the basically Dijkstra's implementation for a weighted graph.
No, I don't have this because
I have implemented it. I
the
can
queue in the
suggest,
chat
like,
room is like from yesterday.
I'm sorry, I can't hear you. Azadi, can you just like repeat what you said or type it in the chat?
Yeah, like I said, I don't have the coding challenge in my queue in the chat room. I just start seeing the chat from 3rd June.
I'm not sure I understand you. You don't have this coding challenge in the, what do you mean, the Microverse coding challenges? What are you saying?
No, in the chat room, I didn't hear quite the name of the coding challenge.
We've sent it in the Slack.
What's it called,
chat room.
coding challenge?
Are you in the? You are in the DSN algorithms. So if
no, I don't have it. Yeah, that's what I am seeing. I just seen all from the 3rd June. You see, I don't have much more. Just from the 3rd June.
Yeah, you're right. We should have pinned it. You're absolutely right. Yeah.
Yes. So, yeah, they have some sort that delete the old chat.
Yeah, we should have pinned it. Sorry about that. So I was looking forward to if somebody else solved it, because I did solve it, but I wanted to see the solution of someone else. Bishoy, Eric, Elish, and Stephanie, have you guys tried to solve the challenge?
No, I'm pretty new, so I'm not familiar with what you guys did before. It's my first time.
Okay, welcome. Glad to have you.
Well, I don't know how I missed it. I don't know how I missed it. I'm just checking from the group, but I can't say it.
Yeah,
last week I didn't join. I wasn't there.
Yeah.
For me, I couldn't solve it, and Ayman, you were the one that actually gave me the solution that I used for using solving it in Microverse. So
no, that was another
it,
challenge.
so.
That was a very similar one, but it wasn't the challenge itself. It's a bit different, like the one that you had. Yeah.
You don't mean it? Oh, I just thought it's the same link, and
it's very similar. Can you guys hear me all right? Is my voice lagging?
Yes.
Okay,
so I'm gonna turn off the camera just so that it's a bit faster.
Okay. Yeah, I think I'll do the same.
If I have it, oh yeah, I'm gonna send the link again. Okay, Bisho, did you solve it? Did you try to solve it? Did you?
No,
No. Okay.
I was busy actually with Rails capstone. So
Oh, okay. This is quite. Okay, so the challenge is this one again. Okay, so I'm just gonna maybe share my solution. I just wanted to give the chance of someone else to solve it because this is, I think, it's quite an important challenge. And I don't know, do you guys want me to just share the solution, or should we maybe leave it to next week and maybe do something else today? What do you guys want to do?
You just share so that
If you want us to push it to next week, I think it will be fine because I was also very busy during the weekend.
Maybe you could walk us through the algorithm without any code.
We did that
And
last.
then
That's what we did last week, and also.
did it?
I did that last weekend.
I missed. I had a test with a company, so I missed the previous meeting last Monday.
We have all of the meetings as well as the materials in the README file, which I'll just share again. So you can watch that for last week. But again, I think this challenge is quite important, and I don't want to take away from you guys the chance of trying to solve it, to be honest. So what do you think? Should we just push it to maybe to next week?
Yeah, I think it will be fine. I think I'll try and work on it this week. I was actually thinking it was the same challenge last week when I saw.
It's very similar, but it's not quite the same.
Yeah. Okay. You can just give us. I don't know. I can't speak for everyone, but for me, I think.
Okay, sure.
If we can push it to next week.
So let's just okay. So this is the challenge itself, the reading material. It's basically asking you to use Dijkstra's algorithm to solve this challenge, which is going from node 0 to every other node. What's the shortest distance? So from 0 to 2, it's going to be 1. From 0 to node 3 is going to be 3. From 0 to 5, it's going to be from this one to this one, and then this and this, which is 1 plus 1 plus 1. That's 4. That's what the challenge is telling you. It's basically output me an array that tells me the shortest distance between node 0 and every other node. So this is node 1, which is 8. Yeah, that's the idea. And this is like the previous challenge that Eric was talking about, which asked you the number of steps that you have to take. So from node 0 to node 1, the number of steps would be 2. That's the idea behind it. The minimum number of steps. We can just forget about this for now. Yeah, so before we go, I just want to prove to you that this actually works, just so that I don't end up wasting your time. Yeah, so it outputs the correct thing. So again, from node 0 to node 0, the distance is 0. From node 0 to node 1, it's going to be 3 plus 5, that's 8. To node 2, it's just going to be 1. From node 0 to node 3, it's direct, and then that's 1, 2, and then 5 is just going to be 4, 1, 1 plus 2. So that's the idea. We start off by just getting the number of nodes, which is matrix 0. It's the thing that they give you. So this is what I call matrix, all of this. And because this is a square matrix, so the number of rows and the number of columns are going to be the same. I'm just getting the length then, and I'm going to initialize some variables that we have that we've seen in the previous challenge. So this is it's an array of arrays. So this is gonna itself contain different arrays. I'm saying the distances, which I'm gonna know, which I'm gonna need. And this is all nodes, which I'm gonna then use to see which nodes we've already passed through. And the number of steps, which we don't really need for now for this challenge, I think. No, we actually do need it because I'm gonna be using that. And then I'm saying that the distance, the idea is I'm gonna be checking if the distance that I currently have is less than the one that I want. So I'm gonna initialize all of the distances to be like a very large number. This could have been infinity, 10,000, it doesn't matter. And same thing, it's the number of steps to get from one point to another one. It's gonna be a very large number. And I'm gonna be pushing the value in all of the nodes. So I'm gonna be pushing all of the nodes to all nodes. I'm gonna initialize the distance from 0 to 0 to be nothing, and the same thing for the number of steps. And then I'm saying the nodes to visit, so nodes that we still haven't visited, and it's just gonna be a 0, 0. In this case, why am I using like two numbers? Yeah, it's gonna be from 0 to 0. So that's I think that's the idea, yeah. Here I'm just getting the, this is the main loop, right? And here in the beginning, I'm just getting which node to visit next. So we've got two nested loops, one inside of the other. Getting the minimum value, next node I'm saying nil. This is just to initialize, and then I'm gonna go to I'm gonna be going through the nodes to visit. So initially this just contains 0, and I'm saying if this is like if this node, the first one, nodes to visit, is less than the minimum value. Oh no, so this is the node that I have to visit, and this is the distance. The distance to get to it. So I'm saying if this one is less than the minimum value, which I set to a very big number at the beginning, I'm just looking at this array, and I'm seeing, okay, which path should I go to next? Which one is the shortest path? So if it is less than the minimum value, which I'm gonna be constantly changing in this loop, just change the minimum value and change the next node. So this is just like a function that gets which nodes we have to go to next. Yeah, and then I'm just removing this one that I put here to the nodes to visit, because now we're going go to it. And now we start the main loop. I'm saying for the next node dot 0, which is basically all of this, I'm gonna be looping through each one of these items. So I'm gonna look at all of the possible moves that I can do in a node. So again, I should maybe explain a bit of this matrix. They explain it in the README, but like just to iterate. So this array just shows you where I can go and the distance. So from node 0, I can go to node 0, 1, 2. I can go to node 2, and that would take me 1. And I can go to node 3, and that would take me 3. Like the distance from 0 to 2 is going to be 1. And this is from 0 to 3 is going to be 3. So let's say we have node 4. Can I zoom back? Yeah. So 0, 1, 2, 3, 4. So again, from node, is this 0, 1, 2, 3, 4? No, this is the one. Yeah. So to go, I can go through node 0, 1, 2, and that would take me 1. And I can go to node 3, and that would take me 7. That's the idea. So here I'm looping through all of the distances of a specific node, and I'm saying I want, this is the distance, and I want the specific index, because the index is gonna tell me which node I'm going to. Yeah. And I'm saying if the distance is equal to 0, I just wanna skip it. You know, it's because I don't have any distance there. I'm saying if the number of steps what's the index plus. What am I doing here? Is this let's see. So this is again, okay. So here, what am I checking? I'm checking if the number of steps that I need to do to get from this should be like, this is a little bit confusing because it should be kind of the other way around. But I'm checking if the current number of steps that I have plus 1, because I'm gonna be adding 1, is less than the number of steps that I currently have saved in the index, which again is, you know, we initialize it to be a very big number. So really, I should be writing this kind of the other way around. But basically, I'm saying if this is less than this, which is the same as, I think, bigger than, I'm gonna be updating it. So I'm gonna be saying number of steps is equal to this one plus that. So let's say that I wanna go to node 1. No, let's say that I wanna go to node 5 and I wanna go through it in this one. So I'm checking the number of steps that I have to do. And if it is less than the number of steps that that are required, like that are already available, that I'm just gonna, you know, I'm just gonna be adding 1 to that. Same if distance x node. Let me just check something because I kind of reuse some code. Yeah, so this is, this was for the, sorry, my bad. This was for like the previous, this was for the previous challenge. And in this challenge, they just wanted the number of steps. So for example, from node 0 to node 5, the shortest distance would be 0, 2, 4, and then 5. So that's 1, 2, and 4. However, the shortest number of steps, that would be 0, 2, and 5. So this one just asks you for the number of steps, and this is asking for the distance. But it's the same idea. I'm saying if the distance, which is what I'm getting here in the loop, if the distance from this node to this node plus the distance that I currently have, so let's say I'm at node 4. If I want to go to node 5, so I'm saying the distance from 4 to 5, which is 2, plus the distance to get from 0 to node 4, which is going to be 1 plus 2. So distance, this one, plus the distance that I already have for this node is less than the current distance that I have stored in this variable. Then I want to update it. And then I want to nodes to visit is going to be push, which is basically visit the next node. Yeah, and that's basically it. So again, we're using 3 different. We're using the. Actually, do I need the number of steps here? Nodes to visit. No, I think I don't even need this. Actually, no, do I? Steps, challenge 13, yeah. Yeah. So again, here we have 3 different pieces of memory that we're keeping. We're keeping the distances of all nodes, the distance of all of the nodes from 0, all of the nodes that we currently have visited, that we have, and the visited nodes, which is basically the nodes that we still have to go and visit. Yeah. So I don't know, any questions, any Any comments? Any ways we could improve this? I see some new people have joined. Has anyone solved this challenge? Udak and Daniel, I think.
I did try to implement something here, but I think it's not willing to work. Let me start share screen, but I did follow up with the same step as you did, but something is really. So you can see here, I modified the parameter here. You can see I added the node and visit as an array, so it starts from 0. But when I'm trying to run it, it's go deeper.
So are you trying to do it recursively?
Yes.
Okay, that's
check
like okay,
recursively.
that's nice. Yeah.
Yeah, but it's go deeper. I think I will just work on it maybe to see if it's gonna search.
Okay.
Yes.
So another thing I wanted to talk to you about, talk to you guys about, it's in the American time zone, they're gonna be starting linked lists. So this is like a topic that we've gone over a few times already, I believe. So is there anyone that wants to maybe try and if you have time and explain it, and go there and explain it. It's still gonna be today, but like at the later date.
I don't know if I can make it at that time because I need to do something after. I think they start at 4 p.m. in
not sure
Universal Time Zone.
what the time zone is. It's 7 p.m. for me, so I'm not sure. But yeah, they start later.
I don't know which time they start, but I think it will be maybe 3. Maybe I will be. Maybe I'm not. I don't know because I'm stuck in the middle of something here. And I need to fix it before I can.
I'm asking you just if you guys have some time, if you wanna try maybe and go and because I think we're quite
maybe maybe if they started.
Sorry.
Yeah, I think I will be there.
Okay.
Time zone.
So IT might have to go. Okay, so Nick is leaving us. Do you guys want to talk maybe? Okay, do you want to show us how you implemented the tree? Maybe, Zari.
Okay, yeah. Okay, this is the which one? Oh, this is the thing here. Just like this. Okay, so the tree. This is the tree. This one. Yeah, this is the tree. So I'm just adding some index parameter to check if the index. So I'm returning if the index is equal to nil. I'll start at 0. Then I'm doing the left.
Just explain.
So the node tree.
Can you just explain the problem before?
Yeah, sure. Yeah, the problem is simple here. So they want just to count the tree, how is solved. So the index here is started from the left to the right. So they want to see if there is any leaf appended from the node, from the parent node here. They want to see how the tall is the leaf is. So like we did see in the previous challenge, this is a node and this is a node, parent node, this is a leaf, and this is a leaf also, and this is a leaf. So when you are trying to search the tree, you need to search how much leaf they have. So from here they have 1, 2, and 3. So we don't count this one because it starts from 0. So we do it recursively, like you said before. So here we check in if the tree is started from 0. as an index. Then we search from the right and the left how much they have leave. So if they have, we show the results. If not, how much they have not inside. So this is the RSpecs. You can see here there is some RSpecs. Quartz was failing. I used to see the RSpecs how they expect to see 4 at the beginning for node and 4 for 15 node also. First 3 of 15 node they expect to have 4, and the second also 15 they expect to have 4, and the third one they expect to have 5.
Yeah, and your code for now was not working. So how do you fix it?
Yeah, it's working. This is the final code here. I didn't yet push it, so if you do, let me clear this path. Here, I just do Ruby challenge to reflect the tree. So the node is having 3 as told. So the RSpecs now is not failing. They are all passing. So I'm checking the left from the right plus 1. So if they have plus 1 leaf, it will check the max tree of the right node or the left node. And it will return the total of the node tree in each
I
place.
like that you're very much focused on solving stuff recursively.
Yes, because this is like the easiest way to count. You don't have to search deeper. You need to search just from down to top. It will stop at the right position.
Can I show you a very easier way to do this?
Yeah, sure.
It's like this is gonna blow your mind. It's basically the left tree, it follows a pattern, right? Because this is a binary tree, right?
Yes, yes.
So the pattern is, let me just, what did I put there? Microstring algorithms. 3, 3, 3, 3. How tall is the tree? Oh no, sorry, that was just the tree.
Yeah. How tall is the tree? I think this is the.
Yeah. No, I kind of solved it the same way you did. Sorry, I thought you were talking about another tree. Yeah. No, I very much solved it the same way you did. So I might not have used the recursive one.
Yeah, I think it was the best practice to see how it does work recursively, because sometimes it doesn't work.
Yeah. No, so I just got confused two challenges here. My bad. Yeah. So what do you guys want to do for next week then?
I don't know. Maybe next weekend I'm gonna hopefully start the final thing in the React. I am stuck in a month now, just doing the LinkedIn and the resume.
Oh yeah, I know what you're saying. Like you have to change stuff in the professional skills.
Yeah.
I really want to I want to see how you guys implement Dijkstra's, to be honest. It's again, I'm only being annoying about this because I think it's a very important algorithm, and we've seen last week that it's very much used. So yeah, I do like, I'm gonna pin the challenge again, and yeah, and I do want to see how you guys go about solving it.
Yeah, sure. Maybe in that time we will solve it.
Okay. So I guess I can maybe end the meeting a bit early today. Yeah, and Hope you have a great week and see you guys next week.
Yeah, you too, my
Okay,
friend.
take care.
Fun done, man.
Thanks, Iman.
Thanks for everything. You did great.
Take care, guys. Take care.